Hello friends, I welcome you all to my channel. This video is part of the playlist Maths 11 Limits, where I have uploaded many videos on how to solve problems on limits for various forms of limits. Uh, I've already covered in previous videos uh, the indeterminate forms 0 by 0, infinity by infinity, 0 into infinity, 0 to the power 0, infinity to the power 0, and 1 to the power infinity. In the previous video, I talked about the trigonometric limits when the variable tends to 0. That was part 1, where I solved some very basic problems. In this video, I will solve the problems that I gave in the previous video, which was DPP sheet number 9. Before I get started, I will highly request all of you, if you are watching my videos on regular basis and if you are having benefits out of it, then please consider subscribing to my channel. That will support me to grow my channel so that I will be motivated to come up with this kind of videos on regular basis. Also, like my videos, share them with your friends, and please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so on the left hand side, I've opened the DPP sheet. So let's solve the problems. The first problem is limit x tends to 0, root 2 minus root over 1 plus cos x divided by sine square x. So we have irrational terms in the numerator, and the very obvious uh, first step is to rationalize the numerator so that we get rid of the square root terms. So if we do that, we get uh, we would like to multiply both the numerator and the denominator with the conjugate term so we have this, and after we do the multiplication in the numerator becomes after rationalization, the numerator becomes 2 minus 1 plus cos x divided by sine square x, and we have this term. So in the numerator it becomes 1 minus cos x, 1 minus cos x, and I've already said that wherever you see 1 minus cos x, an obvious choice is to rewrite it as 2 sine square x by 2. And also in this problem we have sine square x in the denominator. So this becomes limit x tends to 0, 2 sine square x by 2, and we have sine square x and root 2 plus 1 plus cos x. So we have sine square x by 2 in the numerator. We would like to create the standard form, standard result of standard limit sin x by x, and also we have sine square x in the denominator. We would like to have sin x by x and then whole square, and then we will adjust in terms that we are adding. So let's bring the 2 outside the limit. So we have sine square x by 2. We would like to have the square of x by 2. So we will uh, square by 4, and obviously we have to adjust the x square by 4, and over here we have sine square x. We would like to have x square and adjust it, and we have the rest term. So this x square and x square will get cancelled, and this 1 by 4 will come in the denominator, and over here we have 2 outside constant, so that becomes half, and we have sine x by 2 by x by 2 whole square. We have sine x by x whole square, and we have the term root 2 plus root over 1 plus cos x. Now we can put the standard results of the limit sin x by x, rather sin fx by fx, where fx tending to 0. We have this form, and we get 1 square, uh, 1 square, and this becomes, if we substitute x as 0 in the expression root over 1 plus cos x, we get root over 2. So this becomes root 2 plus root 2. This becomes 1 by 4. This becomes 1 by 4 root 2. This is the answer. I hope you are following my solution. If you are having any kind of problems in understanding the solution, please let me know in the comment section, and I will do my best to explain them and address them in some future videos. Please do let me know if you are having any kind of issue or problems. Let's see the next problem. Problem 2 says limit x tending to 0 sine of pi cos square x divided by x square. So we can see we have, with sine we have pi cos square x. So when x tending to 0, x tending to 0 implies cos square x tending to 1. This implies that pi cos square x tending to 0, because sine pi is 0. So whenever we see this kind of problems, I have explained this in the previous video, that if you see a sine of fx where the fx is tending to 0, and below we have any other function, we always would like to have create the fx below the sine fx and adjust the fx and proceed further. So we will do the same thing here. X tending to 0 sine pi cos square x, we would like to have the same below, and then adjust this, that we have divided this, we have to multiply that also with the numerator, and we have x square. Cos square x pi. If we do this, the sine pi cos square x divided by pi cos square x, that is becoming 1, but we will be left with pi cos square x by x square. The x square cos square x is 1, but we are having 1 by x square. That will cause problem. It will become infinity, 1 by 0. Mm, cos square. What if we substitute cos square x by 1 minus sine square x? Will that help? 1 minus sine square x. Uh, yeah, sine square x. Okay. Sorry, this method is not. We are not. We did not arrive at a very good situation. So I will not. I will. I won't go in this path or in this route. I will like to solve it. I would like to uh, simplify the given expression a little further. Like I would like to uh, do pi substitute cos square x with 1 minus sine square x divided by x square. So it is common. It is not anything bad that if you try some method, if you think of an approach for solving a problem, and if you get stuck, if you cannot proceed further, you then fall back and try some another approach. Another approach is fine. There is no bad in that. So this becomes sine pi minus pi sine square x by x square x. What is sine pi minus theta? Sine pi minus theta is, I'm not very good at trigonometry, so let me think. Pi sine pi minus theta. Pi minus theta is in the second quadrant. Uh, mm, 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 mm. All sine. Okay. Uh, cos sine pi minus theta is I have to check. Wow, where is trigonometry? I'm not very good at trigonometry as of now. Where can I see? Where can I have? Trigonometry. Sine pi minus theta. Give me a second, friends. Sorry for this. Trigonometry. Where is trigonometry. Oh, this is calculus. Where is 49? 49. Sine pi minus theta. I'm not sure of this. I'm just guessing if this is thing. This is my assumption. I'm not sure of this. Please let me know in the comment section. Sine pi minus theta equals to sine theta. This becomes then sine pi sine square x by x square. Now we can create the pi sine square x, because pi sine square x at x tending to 0 is also 0. So we would like to create that to form the standard result x by pi sine square x, and we have to adjust pi sine square x, and we have x square. So we have 0. Let's bring, we have the pi. We will keep the sine square x by x square, that gives the standard results limit x sine x by x. We'll bring the pi outside, and we have this as sine pi sine square x divided by pi sine square x, and we have sine x by x square. So now we can apply the standard result, and we get 1 into 1 square equals to pi. Pi is the answer. Okay, let's see the next problem, problem number 3. Problem number 3 says limit x tending to 0, 1 minus cos of 1 minus cos x divided by x to the power 4. So let's substitute, rewrite, use this formula. 1 minus cos x equals to sine square x by 2. If we do that, we have limit x tending to 0, 1 minus cos x. We are applying this formula with this, and we get 2 sine square x by 2 divided by x to the power 4. And then we can again apply that formula. And we get this as 2 sine square 2 sine square x by 2 by 2. So we have this 2 sine square. So we get we can bring this to outside, and this becomes sine square x by 2, and we have x to the power 4. We would like to, since sine square x by 2 also tends to 0 when x tends to 0, we would like to create the form sine x by x. So since we have sine square, we would like to have uh, square of this, and we have to adjust that also, square of this. So now this becomes limit x tending to 0. You have sine square x by 2 divided by sine square x by 2, this whole square, and over here this becomes sine to the power 4 x by 2, sine to the power 4 x by 2. We would like to have in the denominator x to the power by 2 to the power 4, adjust the 2 to the power 4, and we already have, yeah. So this is what we did, what we do. We have sine square x by 2, this whole square, this becomes sine to the power 4 x by 2, and we would like to create x to the power 4 by 2 to the power 4 below, so that we can apply the standard result sin x by x. And to adjust this, we already have x to the power 4 in the denominator, so to adjust the 1 by 2 to the power 4, sorry, this will be not here, but this will be over 2 to the power 4. So okay, so if we bring the 2 to the power 4 outside, we get 1 by 2 to the power 3 limit x tending to 0. We have this sine square x by 2 divided by sine square x by 2, this whole square. Now we have sine x by 2 divided by x by 2 to the power 4. So sine x by 2 divided by x by 2 will be 1 at x tending to 0. Also, the first term inside the limit will also be 1. So we get the answer as 1 by 8 into 1 square into 1 to the power 4. This is 1 by 8. 1 by 8 is the answer. Okay, let's see the next problem. It says limit x tending to 0 tan 2x minus x divided by 3x minus sin x. Now, if you divide both the numerator and the denominator by x, we can clearly see the x term will become so let's take x common from both the numerator and the denominator, and we get no, what we do is we would like to create the standard form sin x by x and tan x by x and adjust and do necessary adjustment. So what we do is we write tan x by 2x, adjust with 2x, this becomes this, and also sin x by x and x. Now we can cancel out, we are having x as common from the numerator as well as the denominator. If we cancel that out, we are left with tan 2x by 2x into 2 minus 1 divided by 3 minus sin x by x. So now if we apply the standard result for tan x by x and sin x by x, which are 1, we get 1 into 2 minus 1, 3 minus 1. This is 1 by 2. Remember that whenever you have something like x tending to 0, let's say tan ax, let's say plus minus something, and over here we have cx plus minus sine dx. we always try to create rewrite tan ax as tan ax by ax into ax, and sine dx as sine dx by dx into dx. The x will get cancelled out, and you can put the standard result tan x by x and sin x by x as 1 for this kind of problems, these pattern of problems. So half is the answer. Now let's see the next problem. Okay, let me just write it down. Over here, what we do is x tending to 0, we write it as tan x by ax dx, where a, b, c, d are constant, and sin dx by dx into dx. Then the rest is as easy as you can understand from the solution of this problem. X gets cancelled out and we put the standard result tan fx by fx equals to 1 when fx tends to 0. Also sin fx by fx equals to 1 when fx tending to 0. Let's see the next problem. Problem number 5, it says limit x tending to 0, x square plus 1 minus cos x divided by x sin x. Okay. Mm, 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 hmm. Mm. 1 minus cos x, we can write it as 2 sin square x by 2. 2 sin square x by 2. Uh, sin square x by 2 and sin square x by 2 square this square. Yes, okay. So let's first, for solving problems on limits, it will not be apparent right away where the steps of the solution will go. So never try to rethink, never try to think a lot, never try to think a lot and try to think ahead of steps what it will lead to. Always use your intuition and keep on try to solve the problem step by step. You might get stuck at somewhere in the future, but that's fine. Fall back and try some another approach. So I would like to uh, rewrite 1 plus 1 minus cos x as 2 sin square x by 2. We have x sin x. Not now. What I will try to do is I will create the standard forms. I will like to have sin square. Since we have sin square and x by 2. I would like to divide it by x square by 4. Since I have x by 2 sin x square x by 2, I would like to have the square of x by 2 the denominator to apply the sin x by x standard result, and then I have to multiply this for adjustment. Over here I will do the same, sin x by x and multiply it x. So I have added the x in the denominator and I have adjusted it by multiplying the x. Now this becomes as you can see, we have x square common from both numerator and denominator. So let's write it x square, and this we have 1 by 4 and this we have 2, so half sin square x by 2 divided by x square by 4. This we have the denominator, we are having this. So x square gets cancelled, and what we are left with is 1 plus half sin x by 2 whole square divided by sin x by x. Now we can apply the standard result. You should always remember that this general formula is always 1. Also, this is true for tan x. If x tending to 0, sin fx by fx is 1, and tan of fx by fx is also 1. I have already discussed this in the previous video. Now we can apply the standard results and we get the limit as 1 plus half 1 square divided by 1, and this is how much is this? This is 3 by 2 is the answer. Okay, let's see the next problem. Problem number 6 says limit x tending to 0, 3 sine square x minus 2 sine x square divided by 3 x square. This is actually pretty simple. This is pretty simple because if we split the terms, we get a direct result of the sin x by x. If we split the terms, we get limit. I mean, if we distribute the limit over the two terms, we get this 3 gets cancelled. Sin square x by x square and minus limit. We have 2 sin square x by 3. This is limit sin x by x whole square, and this is limit 2 by 3. We have sin x square and x square. So this was pretty simple problem. Now if we apply the standard result, we get the limit as 1 square minus 2 by 3 into 1. This is 1 by 3. 1 by 3 is the answer. Let's see problem number 7. Problem number 7 says limit x tending to 0, tan x minus sin x divided by x cube. We have x cube in the denominator. So we cannot just simply write tan x by x and adjust the x, or write sin x as sin x by x and adjust the x, because in that case also it will have the form 1 minus 1, which is 0. That won't help. We have to simplify the tan x minus sin x trigonometrically. So it's better we write it as sin x by cos x minus sin x divided by x cube, and this becomes, if we take sin x common, we get 1 minus cos x divided by x cube and cos x. Cos x won't create problem because at extending to 0, cos x is 1. Now, as usual, we will like to rewrite this should not be a confusion, because this is actually 1 minus cos x into sin x. So 1 minus cos x is 2 sine square x by 2, and we have sin x and x cube cos x. Okay. So we would like to have, let's bring the 2 outside. Let's bring the 2 outside, and we would like to create, we have sine square x by 2. We would like to create the square of x by 2, that is x squared by 4, and we have to adjust x squared by 4. We have sin x. For sin x also, we would like to create the x below, adjust it with x. Now in the denominator we have x cube cos x. So this 1 by 4 we can bring outside, and we get half. Then limit x tending to 0, we have sin x by 2 divided by x by 2 whole square, and over here we have sin x by x divided by, we have cos x, because the x cube over in the numerator x square x, that becomes x cube, and we have x cube in the denominator, that gets cancelled out. Now we can apply the standard result, and we get 1 square into 1 divided by 1. This is half. So the answer is half. Let's see the next problem. The next problem says limit x tending to 0 sin ax plus sin bx divided by sin cx plus sin dx. Now this is a very standard form, standard pattern of question, and the solution is, the approach is very straightforward, that we try to create the sin x by x form for all the terms. So we have sin ax by ax, we adjust the ax, and over here we have sin bx by bx, we adjust the bx. In the denominator we have sin cx by cx, we adjust the cx, and finally sin dx by dx, we adjust the dx. Now you can see we have common x from the numerator and the denominator, that gets cancelled out, and we are left with a sin ax by ax plus b sin bx by bx, c sin cx by cx plus d sin dx by dx. Now we can apply for all the sin ax by ax and sin b by bx, all those terms, we can put the standard result as 1, because all ax, bx, cx, dx tends to 0 as x tends to 0. So we get the answer as a plus b divided by c plus d is the answer. Obviously, in this problem, instead of a, b, c, d, it could be any numeric value, any real numbers, and in that case, definitely c plus d should not be 0. That is assumed. Now, let's see problem number 9. We have limit x tends to 0, 1 minus cos mx, 1 minus cos nx. This is also a very standard problem. We can clearly, we should clearly rewrite 1 minus cos x as replace that with 2 sine square x by 2. So we have, using the formula, 1 minus cos x equals 2 sine square x by 2, we get 2 sine square mx by 2 divided by 2 sine square nx by 2. 2 gets cancelled out, and we have sine square mx by 2. We would like to have m square mx by 2 whole square, and adjust to create the standard form, and similarly nx by 2 we would like to have nx by 2 whole square, adjust that. So now these x square mx, these x square and this square gets cancelled out, and so we will have m square by 4 from the numerator and n square by 4 in the denominator. So 4 gets cancelled out, so we will have m square by n square. If we bring that out, m square by n square, we are left with sine mx by 2 divided by mx by 2 whole square, and here we have sine nx by 2 and nx by 2 whole square. So now we can apply the standard result. Sine mx by 2 divided by mx by 2 at x tends to 0 will be 1. Also sine nx by 2 by nx by 2 will be 1. So the answer becomes 1 square by 1 square. This is m square by n square. Okay, let's see the next problem, the last one. It says limit x tending to 0, sine square 4x square divided by x to the power 4. Okay, so we have sine square 4x, sine 4x square whole square. So obviously we would like to create the standard form with the sin x term. Since we have sine square 4x square, we would like to have here 4x square square. Readjust that, adjust that, and we have x to the power 4. This becomes, okay, so this is sine 4x square by 4x square whole square, and over here we have 16x to the power 4 and divided by x to the power 4, which becomes 16. Now if we apply the standard result, sine 4x square divided by 4x square when x tending to 0 is 1, so the answer is 16. Okay, I hope these were some basic problems. None of them were that tricky or any or hard. The approach was very straightforward, using the basic trigonometric identities and formulas, and the formula 1 minus cos x equals to 2 sine square x by 2. It's just that you have to observe the given limiting function and create the standard results like sin x by x and tan x by x or their power and apply the standard results value for them. That was all for the solution. For the solution, in the next video, I will for part 2 of these trigonometric functions, when variable tends to 0, I will solve some more harder problems, and then we will move to trigonometric functions when variable x tends to a non-zero value. In that, we will try to change the variable to 0 and we will solve the problems. So thanks for watching. Stay tuned for my upcoming videos, and as always, please please support me to grow my channel. If you are learning something from my videos, if my videos are benefiting you, then please like them, share them with your friends, and subscribe to my channel. And also, please do not forget to press the bell icon so that you will be notified by my future videos. Okay friends, until the next video, take care and bye.